Hey everyone, welcome back to another binary search problem. This time we're tackling a medium problem with an acceptance rate of 36.60. Don't be afraid, it's actually much more simple than you think. It's LeetCode 633, sum of square numbers. We're given a non-negative integer c, and we need to decide whether there's two integers a and b such that a squared plus b squared is equal to c. So this is basically asking that when we're given a positive value, c, we need to decide whether, when iterating up to 10, if any two values, when iterated up to 10 squared, equal up to the value of 10. And I'll show a visual example for this if you're still a little confused by the explanation. If you don't like visual examples, I'll have a timestamp in the description where you can fast forward right to the code. Otherwise, let's carry right on with that visual explanation. Let's say that c is equal to 8. One box is going to represent the outer for loop, and the other box is going to represent the inner binary search loop. We're going to have a for in range loop that's going to iterate over each value that gets up to the value of 8. And we're going to have the binary search loop inside that for loop to keep the efficiency and cut that split time in half. So how are we doing this? And let me show you. So the in range of up to 8 is 0 through 7. And with a for loop, you're iterating over each element individually. We're incrementing one at a time. With the binary loop, as you guys should know by now, we're going with the middle index based on the start and end points. If you're unfamiliar with binary fundamentals, I do have a video in the description that teaches those fundamentals, and I have a second video that teaches how to get the square root of a value, which I would recommend before this video as well. So with the outer for loop, we're getting the first value of that index. We're going to square it. That's going to be our a value, which we know equals 0. Then we're going to get our middle index for our binary search, and we're going to square that for our b value, which is going to be equal to 9. And we know that we need to do a squared plus b squared and equal it to c for comparison. So 0 squared equals 0, and 3 squared equals 9. And we compare it. So we do 9 equals 8, and we see that it's false. And that is the 9 equals c, which is the same as a squared plus b squared equals c. Now I'm going to show how the binary search iterates after this. So because our value of 9 was greater than our value of c, we need to move our end position down. And remember that our end position is always a mid subtract 1. So we take 7 and we go down to 2. So our new mid position is going to be 1. So we take 1 squared, which we get 1, and the for loop is always going to iterate plus 1. So we have 1 squared for that. So we have 1 plus 1, which is 2. And 2 is equal to 8, which is false. And 2 is less than 8. So we have to move our start position up. And our array size becomes 2 to 3 because our endpoint was at 3. And our midpoint becomes 2. 2 squared equal to 4. 4 plus 4 is equal to 8. And 8 equals 8. So we can return true. Okay, now starting with the parent loop, because remember that we're going to have a outer for loop and a inner binary search loop. For a in range, we're going to change the c variable to an integer, so that way it's no longer a float, and we're going to square root it. I'll explain why at the end of the submission. Don't worry about it now, just square root the c variable. I wrote the square root because I was thinking of the word, but it's 0.5 to the exponent of 0.5. And you want to do +1, so that way the edge casing of one index doesn't get excluded. Start equals 0, end equals C. And you also want to have it casted as an integer here and square root it. Now for the binary search loop that is inside of our for range loop, start is less than or equal to end, mid equals start plus end, divided to the floor of 2, e equals mid, and we need to square our values. So sum of squares, a squared plus b squared, and we need to check our values now. So if sum of squares, which is a squared plus b squared, equals c, then we can return true. Else if the sum of squares is larger than c, if we guessed too high, then we need to move our endpoint down. Else we guessed too low, and we need to move our start point up. And if none of that exists, then that means there is no statement that's true for this, and we need to return false. So I'm going to remove, don't do this for your code. I'm going to remove this the square rooting and show you guys why I did that. And I'll keep the integers because you guys know why we cast integers and floats. That's just removing decimal points. And I'm going to submit the code, and I'm going to show you guys why it's going to fail. All right, it's submitted, and you see that it failed. And this is because LeetCode has an edge case of C for large values. For example, 99999999999. And it's basically saying that it's going to take too long to find that value because we didn't put an edge case for this long integer. So by doing the square root of that value, we're essentially cutting the time by the square root value. We're saying that by searching by the square root, we know that anything past the value of the square root, it's impossible to find. That is a rule in mathematics and not just in coding that requires some mathematic principles. So if we can't find it true by the square root, then anything past that value will also be false. And we see that it passed, beats 5% of users. And again, guys, don't compare your runtime to other users. Not everybody does binary search like they're supposed to by the category of LeetCode. And memory beats 50% of users. Hopefully this video helped with the visual demonstration and the coding demonstration. If not, leave some questions in the comments. Hopefully I can guide you through it. Spaced repetition, go through the binary search fundamentals, do the square root of the value to find x, and then work on this problem next. I definitely recommend doing a few of the easy questions first, and then working on this as your first medium problem. Don't just jump right into this, and hopefully that this type of scenarios help you guys.